All right, this is our intro video for AP Calculus AB section 4.4. 4.4 is an important section. We'll take, as you can see from the calendar, we'll take quite a few days to get this mastered. So, we've talked about before, there are basically two big concepts in calculus, derivatives and integrals. And to this point, we really haven't delved too deeply into how they're related, but 4.4 goes there with what we call the fundamental theorem of calculus. So there are really two parts. Your book kind of breaks it into two parts here. So the fundamental theorem of calculus, we're going to refer to this first one here in the blue box as fundamental theorem of calculus part 1. We might call it FTC1, fundamental theorem of calculus. FTC1, we can refer to it like that, and I think we'll all know what we're talking about. So let's just run through this really quick. So it says if f is continuous on the closed interval a to b and capital F is an antiderivative of lowercase f, then we can evaluate a definite integral by doing this. The integral from a to b of little f of x dx is equal to the antiderivative evaluated at b minus the antiderivative evaluated at a. It really is a pretty simple thing to do. It's much easier, obviously, than those limit sigma setups that we've been doing. And so this is how we will do pretty much all of these from here on out, unless it says use limit sigma. So we'll continue to look through this and do a few examples here in just a second. If you want to boil it down to its most simple process, here is how we evaluate a definite integral with FTC1. First, we find the antiderivative. We've done this quite a bit already. We find the antiderivative first. Once you've found it, we're going to evaluate the antiderivative at the upper limit and then subtract the evaluation of that antiderivative at the lower limit. So in other words, plug in the high limit, plug in the low limit, and find the difference between the two of them. So we're going to do a couple of examples here. I think you'll pick up on this pretty quickly and have a lot of success. So let's take a look at number 1. This says the integral from 1 to 2, so it's a definite integral from 1 to 2 of x squared minus 3 dx. So step number 1 is to find the antiderivative. So the antiderivative of x squared is 1/3 x cubed, and the antiderivative of minus 3 would be minus 3x. We're going to evaluate this from 1 to 2. That's what that vertical line means with the 1 and 2. It means evaluated from 1 to 2. So what I'm going to do now is plug in the upper limit. So that would be 1/3 times 2 cubed minus 3 times 2. And then I'm going to subtract from that the evaluation at the lower limit. So that would be 1/3 times 1 cubed minus 3 times 1. Of course, I just have a little bit of arithmetic to do here, so I will attempt to do that. I think when I do that arithmetic, I get 8/3 minus 6 minus 1/3 minus 3. So we're going to do this without a calculator. We're going to have to just do a little bit of fraction work. I see 8/3 minus 1/3 basically here. So 8/3 minus 1/3 is 7/3. I also see -6 minus a -3. That's really -6 plus 3, so I would write minus 3 here. And then 7/3 minus 9/3. I'm coming up with -2/3 for the answer to this definite integral. So other than the arithmetic there at the end, I think that's pretty straightforward. Find the antiderivative, plug in the upper limit, plug in the lower limit, and then subtract to find the difference. Let's take a look at example 2. In example 2, I think we could do a couple of things before we get started with the antiderivatives and all that stuff. I think I'd pull the 3 out of the integrand, and I would rewrite my root x as x to the 1/2. So once I've done that, I can hopefully successfully do the antiderivative. That's step number 1, so it'd be 3 times, we're going to have x to the 3/2. Now, as we've practiced before, that's divided by 3/2, but I think I'd write it as just times 2/3. This is evaluated from 1 to 4, but I think we could simplify this and make this just a 2, right? So this would be 2x to the 3/2 evaluated from 1 to 4. Okay, so to finish off with fundamental theorem of calculus part 1, what I'm going to do is evaluate at the 4 and evaluate at the 1 and subtract. So it's going to be 2 times 4 to the 3/2 minus 2 times 1 to the 3/2. Take your time here. Make sure that you know how to do the 4 to the 3/2. Essentially what this means is that the denominator, which is a 2, gives you the root that you're supposed to use. So the square root of 4 is 2, and then the numerator, the 3 there, gives you the power. So this is really 2 to the third, so it's 2 times 2 to the third is 8. So 2 times 8 minus, this just ends up being 2 times 1. So it looks like I've got 16 minus 2, which is 14, of course, using Fundamental Theorem of Calculus Part 1. Okay, and then finally we're going to finish this video off with number 3. Number 3 says the integral from 0 to pi over 4 of secant squared dx, secant squared of x dx. So the hope here is that as we look to find the antiderivative, we recognize that integrand as being something pretty special. We've seen this before. Hopefully you remember that the antiderivative of secant squared is simply tangent. So we would write tangent of x evaluated from 0 to pi over 4. And now we're into Fundamental Theorem of Calculus Part 1. So it's going to be tangent of pi over 4 minus tangent of 0. Of course, tangent of pi over 4 is root 2 over 2. We know that from our unit circle work before. And then tangent of 0 is 0. So, of course, we end up with a final answer of root 2 over 2. And hopefully for the third time we have successfully used the Fundamental Theorem of Calculus Part 1. We'll get a lot more practice in class, but I hope that this has been a good video for you. I will see you in our next class.